Today we're in 6.6. We're graphing exponential functions and using the compound interest formula. I know I've got it when I can graph exponential functions, graph transformations of exponential functions, and use the compound interest formula. Some key vocabulary are exponential function, horizontal asymptote transformations, vertical translations, horizontal translations, reflections, and compound interest. So an exponential function is a function of the form f of x equals b of x. That's called an exponential function, and b has to be greater than 0. B is not 1, and x is a real number. So graph the exponential functions f of x equals 2 of x and g of x equals 4 of x on the same axis. So what we're going to do in Algebra 1, you're just going to use tables to start off with, okay? So if I am just plugging in numbers, all right, if I plug in like 2 to the 0 power, that equals 1, because anything to the 0 power is 1. 2 to the first power, 2 squared, 2 cubed, okay? 2 to the negative 1 would be 1/2. 2 to the negative 2, remember you change it like this, so it'd be 1/4. Okay, now let's do the same thing with the 4 of x. We're going to do that on the same 4 raised to the x power. We're going to do that on the same thing. So 4 to the 0 power is 1, 4 to the first power, 4 squared, 4 cubed, 4 to the first power, remember, so we're going to change it to 1/4, and 4 to the negative 2, we would change it to 1/4 squared, which is 16. Okay, now we're going to use those points that we found to graph the exponential functions. So what that's going to look like, I'm just going to plot those points as best I can and try to connect the dots. Okay, so I'm going to do the 2 raised to the x power first. Okay, so I'm going to do this one in, what color is this? Purple. I'll do purple first. Okay, so 0, 1, 1, 2, 2, 3, 3, 8. If I did -1, that would be 1/2. And then I think -2 was like 1/4. So it just comes like this. Okay, so this would look like that. Sorry, it's squiggly, but I'm trying. Okay, that's not bad. All right, now I'm going to do the 4 to the x power on the same graph. So I've got 0 and 1, same thing. 1 and 4. 2 and 16 would be way up here. -1 and -1/4. So this graph looks like this. Okay, now there's a better picture on the next slide, so I'm going to show you that. You can see my graphs weren't horrible. They're a little sad, but that's what they look like, okay? So if we were graphing those on the same axis, that is the graphs that we would hope to get. And you can do it better with a pencil and paper, I hope. All right, so graph the exponential functions on the same set of axes. So we have these now. So we're going to plug in some numbers again for these. So just plot from -2 to 2 for right now. So anything raised to the 0 power is 1, 1/2 to the first power, 1/2 squared, 1/2 cubed. Now, 1/2 to the -1 would actually be 2. And 1/2 to the -2, because you would flip it, right? So 2 squared is 4. Same thing with this, and so anything to the 0 power is 1. 1/4 to the first power, 1/4 squared, 1/4 cubed, 1/4 to the -1, and 1/4 to the -2. So I'm going to use those points to plot these graphs. So you just really use your knowledge of exponents to do that. Okay, so let's try to plot these as best we can. So 0, 1, 1 1/2, 2 1/4, 3 1/8, -1 2. Okay, so this graph, and then it was like -2 4. So this graph is going down, but you'll see that it never ever crosses the x-axis. It'll get close, but it will never touch. Okay, now the next one, we've got 0 1, 1 1/4, 2 1/16. We can't even plot that, it's so close. -1 4, and then this was like -2 was like 16, so it's way up here somewhere. Okay, so if I'm going to graph that, it would look something like this. And that's very hard to graph that perfectly. So those graphs look like that. Let's look at the next slide to see, and you can see that's not too bad. So that's what they look like. Okay, so realize that we're just plotting this based on plugging in coordinates. That's all we're doing. So something to know, right, from the first two examples, when b was greater than 1, the graph goes up. When b was less than 1, the graph goes down. So watch, I'm going to go back to those slides, and you'll see in example A, b was greater than 1. So the graph goes up from left to right. In example B, the b was less than 1, so the graphs go down. As that's what that's showing, okay? Now, the domain for all this is all real numbers, and the range just depends on where your graph is. All right, so now we've got some transformations. All right, so we hadn't translated it up or down or left and right at all in those last ones because it was just b to the x. Now you're going to have a plus c or a minus c out to the side, and that means that it's going up or down. If you have a number plus or minus in the exponent, that signifies it goes to the left or the right. A negative sign in front of the function means that it reflects over the x-axis. So if you recall the transformations that we did, I think in chapter 5, those same things apply now. So graph the exponential function. So now we're just going to plug in numbers and see what happens with the graph. Okay, so if we plugged in 2, 0 plus 2, we would get 4. If we plugged in 2 to the 2 plus 1, that would be 2 cubed, which is 8. 2 plus 2, that's 2 to the 4th, that's 16. 2 to the -1 plus 2 would be 2 to the 1st power, so just 2. 2 to the -2 plus 2 would be 2 to the 0 power, which is just 1. And 2 to the -3 plus 2 is 2 to the -1, which is 1/2. Okay, so let's plot all those that we can on this graph. Okay, so we have 0, 4. 1, 8 would be way up here somewhere. 2, 16 would be even further. -1, 2 would be right here. -2, 1. -3, 1/2. So this graph, we can tell, is going to go, and I said these are way high up. So that graph is going to look something like this. So let's look on the next slide and see their version of what that looks like. There we go. See, that wasn't too bad. So that is the graph that they are graphing. And notice that their lines go higher up than mine did. They're labels. Okay, so let's do this one together. So we're just plugging in numbers to see how this thing is graphed, okay? So what do you think the transformation is going to be on this one? Since it's -1 and it's inside the exponent, that's going to go to the right one. Okay, so let's go back to the last one we just did. And this is +2, so that's going to go left 2. This is -1 inside the parentheses, so it's going to go to the right one. Okay, so let's plug this in and see what we get. So if we had 2 to the 0 minus 1, that would be 2 to the negative 1, which is 1/2. We had 2 to the 1 minus 1, that's 2 to the 0. And anything to the 0 power is 1. Okay, and then we have 2 to the 2 minus 1, and we get 2 to the first power, which is 2. 2 to the 3 minus 1 is 2 squared, which is 4. 2 to the negative 1 minus 1 is 2 to the negative 2, so 1/4. And 2 to the negative 2 minus 1 is 2 to the negative 3, so 1/8. Now let's plot those where we can. So 0, 1/2, 1, 1, 2, 2, 3, 4. And we've got -1 and 1/4, -2 and 1/8. So this graph looks like that. Now we're going to use that graph. So we're going to use that graph to obtain, let's see. Okay, so if we can also use the f of x equals 2 to the x to obtain that graph. And we said before that it shifted 1 to the right, and this blue line is our line. This is the original. And then if it shifted over to the right one, you get what we had in the last example. All right, so we're gonna continue this. Let's see, and then that is what we had. Those are our numbers that we got. Well, actually, this is not. Okay, so use the graph of f of x equals 2 to the x to obtain the graph 2 minus 2. So if we plug in all these numbers into the original function 2 to the x, these are the numbers that we would get. Okay, so if we subtract 2 from each of those, what happens? This -2 means that we're going to go down 2. And you can see that. Okay, so if we take this -2 and we subtract 2 from each of these coordinates, let's see what we would get. So this coordinate would be 0, -1, 1, 0, 2, 2, 3, 6. That gets harder. So we'll just plot these. Okay, so we have 0, -1, 1, 0, 2, 2, and 3, 6 would be up here. So that is how you get the blue line. All right, so you do some of these. Pause the video. All right, so C, you should have gotten that. D, F, and G. Okay, now let's talk about these before we move on. Okay, so 2 to the x, what's happening? In C, we're just plotting the numbers. Now, C looks a little interesting, but realize their count, like 2 is here, so this is actually 1, 0, 1, okay? And then, so some of your points, if you plugged in 0 for x, you would have gotten 1 for y. If you plugged in 1 for x, you would have gotten 2. If you plugged 2 in, you would have gotten 4. So that's how they're working those, okay? D, notice that your rate, or your b, because it's f of x equals b to the x power, is less than 1. So that's why we're going down from left to right. E, this -3 means that we're going down 3. This 4 actually means that it's a steeper graph, okay? this 2, that should be f of x, I'm sorry. This 2 means that it's going where? To the right 2, because it's minus. And then this 1/3 means that it's going down from left to right. And all of these labels are a little bit different, so they may look a little bit different on yours, but they should be similar. All right, this 4 means that it's going to be pretty steep. We have x plus 5, so that should be 5 to the left, and then 2 up. So that's how they got that point right there. All right, let's talk about compound interest. Compound interest formulas are exponential functions used to determine the amount of money accumulated or borrowed. The exponential function is defined by a equals p times 1 plus r over n to the nt. It models the dollars A accrued or owed after p dollars are invested. So the principal amount is p and the accrued amount is a. And the annual rate of interest r compounded n times for each year for t years. So n is how many times a year it's compounding. So if they said monthly, n would be 12. If they said semi-annually, that would be 2. If they said quarterly, that would mean 4. Annually, it would just be 1. So things to know about compound interest. Compound interest is used most in real world situations such as credit card loans, bank savings accounts, and investments. It's computed on the principal plus any interest already earned in a previous period, unlike simple interest that is only computed on the actual principal. Let me say that again. That is the difference between compound and simple interest. Compound interest is computed on principal plus any interest already earned in a previous period, where simple interest is only computed on actual principal. So 3a says find the total amount of owed at the end of 5 years if $3,200 is loaned at a rate of 8% compounded monthly. So again, this is your compound interest formula. It says if $3,200 is loaned, so that is the original amount. 8% is your rate, so you change that to 0.08. Compounded monthly means that n is the number of times interest is compounded per year for a time of 5 years. Okay, so we're going to set this up. So we're finding find the total amount owed. So 3,200 times 1 plus r is 8% over 12 months to the nt. So this would be n times 5 years. So you are going to put this in your calculator at one time. Now, I would suggest putting 1 plus 0.08 divided by 12 in your calculator and hitting enter, and then raising that to 60, because 12 times 5 is 60, and then whatever you get, multiply that by 3,200, okay? That is the order that I would do that. And when you do, you should get $4,767.51. I would suggest that you try that on your calculator now so that you can make sure you can get it. So you can pause the video if you want and try it out on your calculator. All right, Louis borrows $3,750 at a rate of 10.5% compounded monthly. Find how much Louis owns at the end of 3 years, round to the nearest cent. So again, we're going to use this. All right, so he borrows $3,700 at a rate of 10.5%. So move your decimal over. Compounded monthly. Find how much he owns at the end of 3 years. So I'm going to set all that up into this formula. And then when you solve it on your calculator, you should get $5,131.44. Okay, so you try one. Go ahead and pause it. Okay, semi-annually means that it's happening twice a year. So that's something that you need to know. Okay, so you're going to use the compound interest formula. When you plug it in, it should look like that. And you should get $9,479.19. So I know I've got it when I can graph exponential functions, graph the transformations of exponential functions, and use the compound interest formula. Do you really understand? Why do the graphs of exponential functions such as f of x equals 2 to the x, f of x equals 3 to the x, and f of x equals 1/4 to the x all have the same y-intercept? And what is that y-intercept? The intercept is 1 because when x equals 0, y equals 1 in all of the functions, because anything raised to the 0 power equals 1. What is the difference between simple interest and compound interest? I told you all this. Simple interest is interest that is computed on principal only. Compound interest is computed on principal and any accumulated interest.